New capabilities in .NET with Glenn Condron.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. I'm Jeffrey Palermo, your humble host. Make sure to check out www.azuredevops.show for past episodes and show notes. And a few announcements. My latest book, .NET DevOps for Azure, is going to be at the Ignite conference. A-Press is going to have it out on time, and they tell me that it's going to be in the bookstore at the conference. You can get the print book, pre-order on Amazon or A-Press's website now. But the ebook is available and has been available for some time. There's a few channels that you can get a free copy if you come to one of my webinars. Just check that out, and I'll leave it at that. You can also go to bit.ly/.NET DevOps ebook, and special offer for user group leaders or conference leaders, anyone speaking at a local community event. For those in-person events, I'd love to send 2 copies, free copies for you to give away. And to request those, go to bit.ly/.NET DevOps book for community. And also the Ignite conference is coming up, and I will be on the community reporter team. They tell me that I'll have a special swanky badge walking around with a camera crew and interviewing people and making sure that you stay informed. So keep tabs with my Twitter at Jeffrey Palermo, and also my YouTube channel, youtube.com/Jeffrey Palermo. And one other thing, because we got to throw in some commercials here. At the end of October 28th, I'm actually going to be teaching a training class, a real hands-on, deep, immersive .NET DevOps boot camp aimed at lead developers and team architects who want to ship quickly and operate better. And so you can find information on my Twitter feed at Jeffrey Palermo. So let's get into our show today, which I'm really excited about. Glenn Condron is the program management lead of the app platform team within the developer division at Microsoft, focusing all around .NET. And he's here with me today. Glenn, how are you, sir?
I'm good. How are you?
I'm fantastic. We just recently executed another one of the .NET Conf virtual online conferences, 3 days of fantastic content, and you were part of the keynote, and you gave some really interesting demos, and there's some new stuff coming out. And I thought, man, these my podcast listeners just need to know about this.
Yeah, that sounds good. Yeah, so I talked about gRPC and building a service or a microservice for everybody else to use during the keynote. I actually thought it was pretty cool. So because I built that little service and then I deployed it to AKS, and then everybody after the keynote. Everybody after me in the keynote then used the service, which is a cool kind of flow. I didn't anticipate that the whole rest of the keynote became, well, Glenn's thing was okay, but let me make it better now. Right. That was somewhat unanticipated, but it was cool nonetheless.
Absolutely, and there's so much new technology, and we need to go into it. But there's also, Microsoft is changing. We can see it from the outside in, but also. You have a new role. What's your journey been? What are you doing now? What exactly is your responsibility, your purview now? And what's your journey been kind of getting there? So
I have been around for a while now, but I started on a thing called Entity Framework. You might have heard of it. Entity Framework 6, I think, and I was a PM. I came from industry. I was a dev. And then was an IC kind of dev, working on things, started to do cloud-native microservice stuff. I worked on .NET Core since it was called Project K, just doing things like that. And then recently focused a lot on cloud native microservices. What are we building to make building those sorts of things better? What tech do we need? What is missing from the stack? And then most recently became the lead of the team that I was part of before, which is responsible for kind of most of the app models in .NET. So Windows Forms, the core framework, all of the ASP.NET, Blazor, Signal stuff, ML, AI/ML probably, or anything to do with being an app model and building .NET. For the most part, I probably have something to do with at this point. Well, my team does, not so much me.
Yeah. Well,
they're all amazing people. So
yeah. So a few of the things really stood out with the demos that y'all gave at the .NET Conf, and gRPC is one of those, because for the longest time there's been a normal way for just to make a blocking synchronous call from one process to another, and now that seems to be changing. Am I on the right track?
Yeah. So, I mean, you're thinking normal being like HTTP with some JSON. I do a HTTP client. Yeah. So we've gone on a bit of a journey in that API space. So we started with a thing called HTTP Client Factory that you may have seen in some of our previous releases, just to make it easier to talk to get a HTTP client and do those calls that you're used to. And where we've progressed towards is looking around for. One of the things we also did was add JSON. You saw me in the keynote demo. I clicked on the project and I said, add a client reference to this gRPC proto file, which is the strong contract, because gRPC is a contract-based thing. We also did that for JSON, for OpenAPI, for Swagger docs, if you wanted to still do the HTTP JSON, because all that is still perfectly viable and fine. In fact, there are a lot of places where it's really strong and you probably should do it. Like, I can't think of a tech stack that does not have a good HTTP JSON story for a client, but that's not necessarily true of a gRPC type deal. But what we were seeing more and more in the microservices in particular, or at least people doing cloud native stuff, was something it was a strong contract-based RPC. It was fairly simple. And if you think about it, I think for the most people who are doing like REST in quotes, doing these HTTP JSON APIs, for the most part, you have a method, you want to call it, but it's over there. And I want to get some stuff back. And that actually really naturally fits this more of an RPC style as opposed to the kind of RESTful verb potentially, right? So gRPC has a lot of strong industry support. It's got a lot of backing from Google, and a lot of people are adopting it outside of kind of what we normally see historically, what you and I would have normally seen historically in our career as .NET devs. And so, we started to work with Google. We put together, and just to make the .NET experience great, there was already a .NET story for gRPC before we started. All we've done is try and work with them to make it great and do what we can to integrate it better into the stack.
And the G stands for Google.
Depends on what hour it is.
So it might stand for Google Remote Procedure Call, right?
So I believe that gRPC community say that is, or at least the community say that's not the case. And there are a bunch of jokes where, for example, you can see websites where gRPC and the G means something different every time you refresh the page and things like that.
Gotcha.
So it doesn't matter too much.
Right. Well, that's
it may have once stood for Google. That's not what the group, I don't think, wants it to stand for.
Sure. Yeah. Alphabet RPC.
Yeah.
Hey, but the companies, y'all are working together so well, that's there's no drama, even if it did.
It's been great. We've had, Saurabh on my team is posting blogs to the Google blogs, to tell them about our stuff. It's been really great. We've had a really good relationship working together with them.
One of the things that you did in the demo, which really leapt out at me, I'd like you to talk about your philosophy of putting it together this way. You made the backend service, and developers do that all the time. Oh, here's an API, here's the URL to call it. But you didn't actually give that URL to the calling application. You actually published a library that your calling application consumed so that your service owned its own protocol, instead of locking in the client to that over-the-wire protocol. There's an architectural thinking behind that I'd like you to share.
Yeah, so that started as the reason that started is I was looking at what I needed to do for the keynote. So I had the responsibility of building the service. We had this weather idea. We wanted everybody to consume a weather app. And so I looked at all the people and all the app types that I'm making. I had a Xamarin app, there was a Blazor app, there was some stuff doing ML, there was a WinForms app, like all of these different application types, all of these different people who are all consuming my thing. I'm like, well, net standard means that I can have a single set of code that runs everywhere, and none of these people have ever done gRPC before. So I can either share the proto file, which I did do as well, but I can either share the proto file and then say, walk every one of those people through how to go and generate the client code and make everything work. Or as part of this project and this solution, I can generate the client and let them just consume it. And then as you said, it puts the control of the client onto me. And as long as I am versioning in such appropriately, it's okay. And it's a little bit akin to the concept in some ways of doing microservices where a service owns its own UI, right? I don't know that I would do it if I was scaling out to many language stacks, because the burden of that might start to get pretty
Sure.
high. But because everything was .NET, this seemed like the right way to go. And I could imagine even doing this within my organization, especially if I had set up some infrastructure for my own NuGet package feeds where I could publish the client as a NuGet package, and you update whenever you want to update. And you make sure that the service is backwards compatible as you have to when building APIs that many clients are going to consume. And people update when they want to update.
Yeah.
Right. Some people get a little bit nervous about it in the microservice world because they're like, oh, there's a binary dependency. Is this like a mullet microservice where it's like all nice on the front and then massive binary dependencies on the back, or is this actually decoupled nicely? And I think this is an appropriate step that is still okay within the philosophy of why you care about that decoupling in the microservice world, because you're mostly caring about being able to decouple so that you can deploy all of your services independently. And this still absolutely allows all of that, but just makes it easier and faster and better.
Oh, absolutely. And I think probably most of this audience is not developing Facebook competitors or the next PayPal. They're developing software so that their businesses can compete in the marketplace. And so their service interfaces are between different applications at their own company. And so architecturally, they're making these decisions. And that is a fantastic pattern where the service now can actually be in the call stack of the calling application instead of having no idea what's going on until somebody calls out and tells it something. And whether it's caching or rate limiting or just executing some intelligence because it has more context and have a little bit of memory space out there on its edge. It's just a fantastic architectural pattern.
Yeah, with gRPC, basically you generate all of the code that is the client. So the other side of this is like nobody's going to do anything different. What we were going to end up with was 7 versions of the exactly same generated code. No one was going to customize it.
Yeah.
And so why was there a need to have all of them generate that code themselves? Right. That is another aspect of this. And yeah, it all works pretty well. And that thing that you touched upon there, though, which was all of these clients, like a lot of your customers, I'm sure, they're all within the organization. They're all really just talking to themselves, to some extent, themselves in air quotes, right?
Right.
And that is actually where stuff like gRPC really does shine. Kind of, it's binary. But it's binary and it's contract based, but you have an easy way to share the contract to everybody. When you start where HTTP and JSON becomes super valuable is when you're going to expose this thing like a Facebook or a GitHub or somebody, because JSON is just super interoperable and it's super easy for anybody to consume in any language. You can do it via PowerShell if you really want to, right? You can open up curl and just move around an API, right? Yeah. JSON is this super leveling playing field. But if you control all the ends, like you're building the 3 apps that are going to consume the API and you're all deploying them and the teams are only an email away, then creating this like strong contract to really define what the server is and make it be really easy for then all of those clients to consume it is really valuable and time saving. Whether or not you start exposing gRPC outside of that kind of firewall concept, that It may not be an actual firewall because you may actually be exposing this stuff out. But, if you start, whether or not people start actually exposing gRPC in a way that you do today with JSON, it's not technically difficult, not technically impossible, and people might do it. But so far, my understanding is that the tendency is not to do that. It is in that niche of, well, it's a really big niche. It's a really big group, but in that communication with inside the firewall.
So early on in .NET, we used remoting calls, .NET remoting.
Yeah, which is a different form of RPC, yeah.
And it seems like, and I want to get your take on this, seems like anything that is a step higher in compatibility so that a greater reach of clients can use it includes extra steps and a decrease in productivity. Does that relationship tend to be true?
Sure. That can be true. If we talk about this spectrum of kind of .NET remoting, where you're effectively making these RPC calls and you're kind of marshalling memory and you're taking .NET types across, you're locked into an ecosystem in that regard, which is probably good if you care about making everybody be locked into that ecosystem. It's not something that we're particularly interested in these days. But yeah, then you start leveling this up. So now what do you need in order to make something like gRPC, where you can get something that feels like that, but actually works across many languages? Well, now you need a serialization format that can be a serializer that can be used across all of these language stacks. You need to be able to have a common networking protocol to be able to talk across these things. You need many more pieces, right? So it's a lot more complex, yes, but there's also a lot of benefits in that that strong boundary that has been enforced because you want it to be across languages actually avoids some of the pitfalls of .NET remoting, with some of the difficulties that we used to have. So yes, it is more complicated to implement and to build, but for the most part, you're independent of that from a consumer. I would assert that with either of these with many of these kinds of texts, once it's going, you're just calling a method.
This is rock solid.
And you're good. The big complaint there, which has always been the case, is when you make something look like a method call, people think it's a method call. Yep. And it's not. Right? It's doing a whole lot of stuff. It's talking to a network. It has failures. It has network failures. The fallacies of distributed computing come into play, right? You're going to have problems here if you assume this is like reading something from your local, even not even reading something from your local disk is a terrible example as well. But if you think this is just like calling some arbitrary API, you're going to have some pain. So it's important to remember that you are making a network call. This is the same as doing a HTTP request. gRPC is HTTP.
Right.
Right, it's HTTP2 it's just not JSON. It's protocol buffers and it's a different this RPC style of calling things, but it's still using HTTP to do its networking. So
awesome. And you ran this demo in an interesting way. You ran it in a container, right?
I did, in a Linux container. Yep.
So we're all .NET Core 3, and what was interesting about how you ran it? What were you impressed by there?
So I did something that was a bit interesting. With gRPC, you basically are forced into using TLS, using certs. You can kind of make it insecure by setting these kind of app context switches, and so I think maybe even on a Mac you have to do that at the moment because it's a little bit difficult. But you have to do TLS. So a difficulty with containers is managing those certs, right? You got to get them into the container. You don't want to put them in the container when you build. They need to be injected into the container later, right?
They're different per environment.
Yeah, that's right. So how do you deal with that? And that can be pretty complicated. Kubernetes has some stuff where you can create certs and you can kind of inject secrets and you can do stuff like that. I just didn't do any of that. I created an Nginx ingress controller. I gave it a cert. It terminated all the TLS and then did basically clear over to my app. So my app just didn't do any of that in production within the cluster.
Okay.
And so my app is just oblivious to any of those sorts of concerns. So I have this Nginx app. It's talking to Let's Encrypt. It's getting a Let's Encrypt cert. Everybody who's talking to my thing is doing HTTPS. But my actual app doesn't care about certs, and it doesn't have any infrastructure in it to load a cert from files or anything like that. It just says, yeah, I'm clear, I'm good. And it runs.
Okay, so a little bit of special network security group, and some things going on there.
It wasn't very difficult. I have most of the config for that in the repo that we set up. I have some of the like ingress controller rules and stuff for Kubernetes in there. And so once I set that up, well, then I was like, oh, this is cool. And then I could put like a /proto on there to be able to download the proto file from this one URI if anybody wanted to get the proto file to be able to generate their own client. And then it was running gRPC. Then what I also did, which is interesting if you look at the actual implementation of this, I also created a JSON endpoint. And what I did with that is I created a controller, and it just returns the exact same types that were generated from the gRPC proto contract. So I have this one type that gets generated from the proto file, which was my like weather response. Right? I define the fields. And I return that both from a gRPC endpoint and from a JSON endpoint. My controller is one line of code. It's just go make one of these things and return it. And it just leverages all of the gRPC side of the code.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So walk us back a little bit. Nginx, what is that running as in Azure?
It was a container running inside my Kubernetes container. Cluster. Yep, one more container. Okay,
so single cluster.
Yep.
And that just happened to be one of your containers. But then talk about the networking. What did you configure in the network to get it to be in front?
So I create, there's a guide on Azure, there's a doc about how to set up an Nginx ingress controller to do TLS. I basically followed that doc, and I doodled around and copied and pasted stuff and ran commands I didn't understand until I finally worked out what was going on.
Yeah.
And so what you do there is you set up a number of Nginx containers. I think I set up 2 or 3. I had a few running because I was always scared that someone was going to leak the URI and all your people who were listening were going to start hitting this endpoint and it would go down in the middle of the keynote because it was all public. Like there was no secret author or anything on it.
Yeah.
And so it's this, you download this Nginx, you create a pod for this Nginx, which is a Kubernetes concept. I basically run 3 containers. They all have the Nginx reverse proxy running inside of them. And then that Nginx has a configuration that says, for this URI, go do the Let's Encrypt dance. That's a plugin for Nginx. It knows how to go talk to Let's Encrypt and get the Let's Encrypt cert and do some stuff like that. You run a few commands to be able to run. There's actually some extra containers in there that actually do that, but we'll gloss over that. There's some plugins for Nginx that know how to do the Let's Encrypt stuff. And then I just configured the back end of that to be the service name for my weather app that was actually running. So whenever you hit this proxy, it would whenever you hit this URI, it would proxy over. And I had a fully qualified domain name from Azure that I created. This is all just done via typing commands in the Azure shell, one after another, until I had a thing that was working. And it was it ended up being pretty nice. The only extra thing I needed on top of what's in the Azure docs on how to set this up manually was an extra command to tell Nginx that it was a gRPC to do HTTP2. Basically, they have a special command for They basically have a special setting for gRPC to say do a gRPC here. And that's in one of the Kubernetes docs in the repo as well. But that was all that was really special about it. Otherwise, it was all vanilla. Make an Nginx ingress controller with Let's Encrypt. They're the keywords you should go Google for. Kubernetes, Nginx, ingress.
That's a pattern that could have pretty wide applicability in DevOps pipelines that are targeting Kubernetes when the release candidate package format is a container, when the code is .NET Core, and in Azure pipelines, they're packaging up the container. And just to know, hey, I don't have to worry about injecting configuring variables, we always do, but injecting a cert, I just architecturally raise that cert up the network stack.
Exactly.
And that's going to be a runtime component that gets deployed much less frequently.
Yeah, that's right. I think with microservices in general, architecturally, you need to start thinking about you can leverage the cluster and the network to do some stuff that historically you would need to do in your app, and you should start thinking about up-leveling that. That at the end of the day is kind of what mesh networking and Istio and stuff like that is doing. Is saying let's try and take more of the kind of substructure of the environment my app is running in and use it to great effect. Right. So at the end, all of my my container that was actually running the talking to the weather API, the only thing it needed was a single token to actually auth to the backend to the actual thing I was talking to on the internet.
Nice.
And I did that with a Kubernetes secret. In .NET has a Kubernetes config loader that just knows how to load config from the format that Kubernetes injects it in. It was all pretty trivial. And so yes, that architectural concept of pushing what you can into the network or into other locations to make your little service be as simple as possible, that starts to become important. Being able to set up something like an identity server to be able to do auth in a normal auth world, right? So it's its own service. It just does auth, and everybody else just has the libraries to communicate to that thing. Now, you don't have that sort of logic embedded in your thing to be able to validate tokens or any of that, right? These sorts of concepts are things that you have to start that you don't have to, but you're going to end up starting to do because you're going to want. And what was the thing that kind of highlighted that is, these things kind of deploy independently, as you touched on, which is one of the things that you want to really start looking at is what are the things that I'm going to deploy that I want to deploy on their own, that deploy independently, because I want to make every one of these chunks be an independently deployable unit. And the rate that I update the certificates and have to do a redeploy or a touch of the Nginx is significantly different to the rate that I'm going to redeploy this weather API. Right. So if I don't have to couple those two things together, why would I want to do that?
That's right. And if they deploy at different rates, then the versioning is independent. And then most of the time, almost all the time, that's an independent Git repository from a DevOps perspective.
Absolutely. Yeah. And so they're the things, these are the sort of concepts. These are some of the brain pivots that you kind of end up making when you start thinking about this world.
Mm-hmm. So a Blazor app was also layered on using the same client. And now was the Blazor app, was the Blazor app deployed to the same Kubernetes cluster?
It was not, but it was not. I don't think we ever actually deployed that app to Azure, but it could have been deployed to the same cluster. I think in the end we only ended up deploying just the service, and everybody just talked to it during the keynote from their own
machine. So that was
machine.
just running locally on the machine as a sample. Yeah. Got it. Okay, but that Blazor is out.
It is, and so conceptually, what you would do is deploy and put a second container down. That probably the same Nginx ingress controller, set up a secondary route that routes to the Blazor application. It would serve you the Blazor app, and then the Blazor backend would be communicating within the cluster, just talking to the other to the other service is probably the way that you would set it up, so that it wouldn't have to go back out and back in through the ingress controller anymore.
Okay.
Right. One of the nice advantages you get from the Blazor that we shipped in 3.0 is you get that feel of a spa, but you still can just talk directly on the back end, and there's no sandbox and there's nothing that you're worrying about. So you just do what you want there, which means in this case where I'm inside this AKS cluster, I can talk just normal service to service communication. I'm not having to do anything special in there. And I don't have to worry about any restrictions where if I was to go to like a full spa client side in a browser, I'd have to worry about sandboxes and how do I communicate out and does it work in WebAssembly and things like that.
Right. Yeah, I think that Blazor has capability of creating greater productivity for teams that are already .NET teams by just not having to shift back and forth between completely different development ecosystems and sets of tools and just everything C# and C#. Well, then you got HTML, then you got CSS, then you got SQL, and you still have your soup of languages.
Yeah, you're not really getting away from being polyglot to some extent, but it's nice to extend to single languages as much as possible when it makes really nice sense. Now, before WebAssembly, we would have done this without we could have done Blazor. And we may have done Blazor, server-side Blazor as we ship now because it doesn't rely on WebAssembly in any way. But in the past, before this, we tried a lot to help .NET developers be better with the existing ecosystems. We went for a long time chasing this. Let's just help people do a better JavaScript and stuff like that. And it was just hard for us to keep our customers up, to keep all of the people who were .NET customers up to date. We would put Bower.
Right.
We shipped all of our templates. They had Bower in them, and you used Bower because that seemed like what everybody was doing. And by the time that started to gain adoption in the .NET space, Bower was gone. Bower was dead. Everybody was using NPM, just NPM for that effectively.
Right. Well, .NET, I mean, the .NET runtime, everybody understands, this is the programming model, and this is what it means to be an app domain, and this is how memory works. And they just know how to run .NET.
Yeah, you get to share your knowledge, right? Like what an object is and what strings are, and that when you need to make a new thing versus that like what's immutable and what's not immutable. You understand how all of that stuff works. Even if you can't articulate it, all of you people out there that are like, I don't know what immutable means, or like, I don't know what boxing is, or anything of that stuff. Even though you don't necessarily know you can articulate that, guarantee you have a fairly good kind of intuitive understanding of what is good and is not, and what can and can't work, which is all a mix, just a gestalt of all of those concepts of the .NET runtime and the way that the runtime works that you've been absorbing via osmosis over all this time that you've been a .NET developer. And all of that knowledge still transfers, whereas the biggest problem with JavaScript is that it looks so much like either Java or C# that everybody thinks they can write it without understanding what it does.
Right. Which is just like doing remoting without knowing it's going across the network.
Exactly. So you jump into JavaScript and then you write some code that looks like C#, and they're like, damn, that doesn't do anything like what it was supposed to do when I was in C#, right? Even, this you didn't put enough equals here. You need like 7 equals signs here.
Yeah, the triple equal. Exactly. It's like, who would have thought a triple equal?
But and there's all the famous JavaScript what-thers where you're like this where what is this? These 3 things are all equal in JavaScript, right? And if you go searching, you'll see all of those crazy things, right? Understanding all of that is not something that you have, and it's not something that you've absorbed. And if you haven't jumped in and learned all of that yet, this .NET, using .NET everywhere seems real attractive.
Right.
But we're also not forcing you. So if you really love JavaScript, go for it. Don't take any of this as anything except a loving criticism of JavaScript.
Well, I first started writing JavaScript when you could do hardly nothing with it, because you had to write an Internet Explorer 2 and a Netscape 3 version you had different websites and just the little JavaScript snippets in the mid-90s that you kind of sprinkled in here and there.
Yeah.
And now it's grown. And so 22 years. Yeah, I've known JavaScript for 22 years. And you know what? For 22 years, I've had to use JavaScript. I've never wanted to do JavaScript or loved doing JavaScript. I had to. And so now Blazor is, I have to do less JavaScript. This is awesome.
Yeah. And server-side Blazor is also pretty interestingly unique in the ability to write C#, interact with the UI naturally, have it look like JavaScript, have it look like a SPA. There's no postbacks, there's none of that. It feels like exactly how I want my web app to look, but I can just do anything because I'm actually on the server whenever I want to be on the server. It's so like liberating, right? It's like, I'll just do a HTTP call here and there's no problems. I'll just write to file. I'll just read this file or write to disk or do this thing that I've always done on the server of my app, and everything is great.
Right.
And that's amazing. Like, especially if you've come from building MVC or Razor Pages or web forms or Ruby on Rails or any of the server-side web frameworks, if you're coming from any of them straight to this and you're not going via Angular or any of the current SPA frameworks, then this is amazing.
Yeah. Well, let's get one more opinion in. Okay. Because we're tail end of the show here.
Yeah.
So I'm sure you work with your counterparts on the Azure team, and they have multiple ways that you can run a Docker container. And with .NET Core, it's all about, hey, you have options in how you want to run. You can run on the Linux kernel or Windows kernel. And so out of all the options for being able to run your .NET Core application in a container, which is the one that's your preference at the moment? What should be the normal? It's like, you know what, most of the time you're going to target this unless you have some scenarios that carry you to something else.
It's a little bit nuanced. I might have a different answer for you if you ask me this question again not that far away.
Okay.
But
Continue.
if you're building a web app, then Azure App Service is still great.
Mm-hmm.
Right? It supports containers. You can give it a container. If you use Linux, you're running in a container, even though it's just kind of hiding to be Linux. But you can just give it a container, say run, and it runs. You get an endpoint, you got a URI, you've got all the stuff that you want, right?
And that's Azure Container Instance, right?
No, that's Azure App Service. It's Azure App Service for containers.
Okay, the official name now is Azure App Services for Containers. Got it.
Yeah.
Okay.
If you used it early on, if you used Azure App Service for Linux early on, you used to be able to choose between either using their image or using your own. Now they're kind of two services.
Yeah.
So you either create an app service and it's either Linux or Windows, or you create this thing called an app service for containers. So if you're just building a web app, and you want to use a container because you're liking the way that you build containers, you like isolating the build pipeline, you want to put that into your repo, you want to have Azure do a thing, you're just doing some good DevOps work where the actual all of the infrastructure, all of the requirements and artifacts required for build are in your repo. You want all of that benefits out of container, which they're amazing for, but you're otherwise just building a web app, like there's nothing super fancy about it. App service, go, right? It's amazing, it's simple, it's easy.
And that's what acronym police. ASDO is short for Azure DevOps Services.
Yes. Yeah. And it's just whatever your build pipeline of choice is, right? I blame the cloud developer advocates for the ASDO name. But anyway.
It only makes sense. I mean, everything in Azure is A, lowercase z, and then something.
I mean, we had nupkegs, so it makes it, I guess we can't throw stones about our names. So that for your web app, right? Where it starts to get more nuanced is like, oh, I'm building a thing that's talking to a message queue or something like that, or I am wanted to kind of build microservices and I've got several containers. I all want them to work and I want them all to talk together. That's where you start needing things like AKS. But AKS is complicated. I don't think anybody kind of claims that it's not. Learning it can be difficult, and I think. If this is about opinion time, I think we will see more and more higher level stuff built on Kubernetes, where you'll get some of the benefits and be able to run those multi-container applications together without necessarily being exposed to as much of the complexity of being able to deploy. That's what I predict and hope for in the not too far away, where everything is at the end of the day, the future kind of is everything is a container. The containers are a unit of deployment. We've in fact experimented with, and if you all think this is an exciting idea, you should tweet me about it. We've experimented with a .NET command tool to be able to push a .NET app directly without a Docker file and not actually necessarily using Docker, push an image directly to a registry. So you just go like image go, and it goes, and you have an image, and that can be a side effect of your build. It can do whatever you want. You don't even necessarily need Docker to do that now with the Open Container Initiative kind of movement, where we could just build an image and you just have an image and put it on a registry whenever you want. We could make it super fast.
Well, I'll speak for my listeners. I will, because and I'm not talking about the technology companies that are pushing stuff forward. I'm talking about people building software for their companies. They want, the fewer the buzzwords, the better.
Yeah.
They want to say, oh, my app runs. I want to run a command, do my pipeline, and just say, hey, here's my app. Run it. Now, if you're running on a Kubernetes under the covers and it's all fine.
Yeah, great.
What's the package format? Well, guess what? At one point, it was a zip file, but I didn't invent zip. So if you're telling me now that it's a container and when I hit the button, it wraps it up in a container instead, I don't care. Yeah. Here's my app. Run it.
Exactly. There's an interesting mantra that I've really liked from the Cloud Foundry Java ecosystem, and they have this like code that they say, which is, here is my code, run it on the cloud for me. I do not care how.
Absolutely. I mean, God, just the number of concepts that have to be in their brain just to get it functioning the right way and keep the data secure. And all. Gosh, we don't need more. We don't need more of all these, 2 levels deep of the infrastructure. What went wrong? The code's working fine. Oh, this little twiddly bit in the infrastructure.
And that's really what we're trying to get to with containers is the shipping container analogy. Get it to containers, and you can get it to containers today. There is a lot of benefit of using Docker files to define your build environments. And I think once you start doing that, you're going to fall in love with it anyway. So that's kind of fine. Then get to a container. deploy your app to the places you can deploy them today. Azure App Service is great. It's simple. You don't care about Kubernetes or any of that stuff. But now you're in a container. If you want to move to Kubernetes tomorrow, it's trivial because you're already in a container. And anywhere, just like shipping containers, a shipping container can be unloaded on any dock that knows about shipping containers. Right. Any of the platforms that are container-based can run your container. Yeah. And that's the world that you want to get to. So that's why we believe that containers are be the unit of deployment of the future, and everybody will at some point always be publishing in containers. To your point, they may turn into being something like zip files where you don't care about them or how they work. They just happen to be the thing that happens. But we will see. There's lots of movement in this space, so it's exciting times. It is. We don't really know what the future will hold, and this is a very different experience. If we had this podcast, if we had talked about this kind of more futuristic stuff a couple of years ago, it would have been completely different. At that point, there were effectively still 3 or 4 people competing for the orchestrator of choice. We would have had to have this whole tangent about DCOS and all of these other things that the people were running containers on, and we didn't really know Docker Swarm was being built. Right. We didn't know any. We didn't know there was this big ecosystem of all these different orchestrators and all of these different things. Now it's only really Kubernetes. Right. So that only happened over like 2 years maybe. Yeah.
At some point, the industry has to agree on what the width of the train track is going to be.
Yeah, that's right. And if any of you don't know about any of the history of deciding on the standardization of train tracks or any of that stuff,
That's right. All right. Well, thanks so much, man. This has been a lot of great material. I appreciate you being with me. For people who want to kind of learn more, they can get all of the recordings at this point of .NET Conf?
Yeah, all of the .NET Conf stuff on Channel 9 or YouTube. I think maybe even on Twitch. On the Visual Studio channel.
Twitch.tv/Visual Studio and YouTube.com/Visual Studio.
I believe so. Yeah, I believe it's the YouTube/Visual. I believe it's YouTube.com/Visual Studio. If you search for .NET Conf, it'll take you to Channel 9. At least it does on my machine.
And the GitHub repository?
Yeah, so there's a GitHub org called .NET-presentations. And it has a repo for a bunch of different presentations that we've done. .NET Conf is one of them. And it has all of the slides from all of the people. And there's a directory called technical. And in there is also keynote, all the keynote source code.
Okay, so github.com/
.NET-presentations.
.NET-presentations. Perfect.
Yeah. And in there is a lot of presentations and a lot of slides. So if you want any of the slides, any of the demos from the keynote, I don't think everybody checked in their demos, but we did put the keynote demos in there. Mm-hmm. And it's the keynote demos as they were when I last pushed them to the server, which means it's actually very different to what you saw me do on the demo code in the video, because I didn't actually push the one that I showed in the video to the cluster. So it has cores and JSON, and it has it has a whole bunch more complexity because not lots, but bits of extra complexity to handle the different people, all the different folk who were hitting it.
Yeah. Awesome.
Yeah.
All right. Well, wow, Glenn, thanks so much for being with me. This is a great topic.
Yeah, I had fun. Anytime.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.